The first set says each of the 5 automobile manufacturers recognized by the brands A, B, C, D, and E manufactured 2-wheelers and 4-wheelers in 2009. The given clustered bar chart shows the number of total vehicles in thousands manufactured by each of the 4 brands out of 5 blue bars, and the percentage of 2-wheelers manufactured by the respective brands out of the total 2-wheelers manufactured by the 5 brands put together, which is the orange colored. Excuse me. So as the question says, there are 2 parts to this. The one is number of vehicles manufactured in 1000 units, and the other one is the 2-wheelers as a percentage of total number of 2-wheelers manufactured by the all the 5 brands. So the percentage part is given by orange, okay, and the blue bars is about the total number of vehicles manufactured. So let's understand what this is about. So if I talk about brand A now, the total number of manufactured vehicles is between 24 and 26. So we're looking at the blue one. So total vehicles manufactured is 25,000. Now, out of these, there are going to be either 2-wheelers or 4-wheelers, right? Now, how many 2-wheelers do we have? So in order to look at the 2-wheelers, we need to look at the orange bar. This is 10%. This is along this 10 part, right? So for this, we'll have to look at the right hand side graph, which is 10%. So this is 10% of 25,000? No. The total number of 2-wheelers that we have is, let's say, X. This is the total number of 2-wheelers. Okay. Then the number of 2-wheelers in brand A is going to be 10% of X. So how many 4-wheelers are we going to have? It's going to be 25,000 minus 10% of X. Similarly, if you talk about brand B, then in brand B, if you look at the blue bar, we are looking at 30,000. That is the total. And if you look at the orange bar, this is going to be looked upon on the right hand side axis, which is going to be 20% of X, where X represents total number of 2-wheelers that are manufactured by these 5 brands. So this is 2-wheelers. So the number of 4-wheelers is of course going to be the difference of these two. Total 30,000 vehicles, out of which 20% of X is about 2-wheelers. So this is going to result in total number of 4-wheelers manufactured by brand B. And henceforth, we have to do the similar thing. Since we don't know how many total 2-wheelers are manufactured, we have no idea as to what X is and what expression is going to result when it comes to 4-wheelers of each brand. So let's look at the questions and understand how to proceed, how should we interpret everything, and how should we represent it. Should we draw a table, or is it like nothing of that sort is required? So the questions will help us decide how to go about this now. So if you look at the questions, the first question is, what could be the maximum number of total vehicles manufactured by brand A? Next question is a theta question. If 50% of total vehicles by brand C are 4-wheelers, then what is the number of 2-wheelers? So looks like we need to know the number of total vehicles, 2-wheelers and 4-wheelers for all these 5 brands. If we draw a table for that, we can go ahead, write down the expressions as such, and depending upon questions, we are going to choose the expressions or the values as required. So the bar graph that we have is here. So let's talk about filling up the table. So the total brand A vehicles we have is 25,000, right? So this is 25K is I'm going to write. Excuse me. So we can either fill up the total first and then 2-wheelers, or we can straight away go ahead and fill column wise. Completely our choice. I will get done with the blue bars first, as in I'm going to go row wise. Brand B, the total number of vehicles is 30,000. For brand C, the total number of vehicles is 24,000. In brand D, the total number of vehicles we have is 18,000. And brand E, we don't know what is the total number of vehicles. So I'm going to call this as E. So total number of vehicles, if we add, is going to be 25 plus 30 plus 24 plus 18, which is going to be 70, 80, 95. So this is 95,000 plus E. This is the total number of vehicles. Total number of two-wheelers, if I say is X, right? Then the number of two-wheelers of brand A is going to be 10%, right? So we have to now look only on the right-hand side axis. So this is going to be 10% of X. For brand B, it's going to be 20% of X. For brand C, it is going to be 30% of X. For brand D, it is going to be 20% of X. And brand E, so obviously total will be 100%, out of which 10, 20, 30 and 20, which will result in a total of 80 here. So 80% is already taken into account. So brand E is obviously going to be the remaining number of two-wheelers. Now, if you talk about four-wheelers, the four-wheelers of brand A is going to be total number of vehicles minus the number of two-wheelers. Similarly, for brand B, it's going to be 30,000 minus 20% of X. For brand C, it's going to be 24,000 minus 30% of X. For brand D, it's going to be 18,000 minus 20% of X. And for brand E, it's going to be E, total number of vehicles by brand E, minus 20% of X. So the total number of vehicles is of course going to be the difference between these two, which is going to be 95,000 plus E minus X. So having filled the table, we can now go ahead and try to solve questions. Whatever is required, we will be using the table. So let's begin. So let's solve the question number 1. So question number 1 says, what could be the maximum number of total two-wheeler vehicles manufactured by all the 5 brands together? So we need to maximize the value of X from here, right? Now, how do we maximize the value of X? Value of X can be anything, right? Let's say value of X is 100,000. If value of X is 100,000, then 10% of 100,000, 20% of 100,000, 30% of 100,000 and so on. If we calculate those values, then two-wheelers will not be a problem. There will be some value or the other, but four-wheelers should not turn out to be negative. Okay, so there are 2 ways to understand this. Okay, the first is if I assume the value of to be a random value which says, let's say X as 100,000, right? Then brand A, if we talk about four-wheelers, brand A is going to be 25,000 minus 10% of X, which is going to give us 15,000. Brand B, it's going to be 30,000 minus 20% of X, which is 100,000. So 30,000 minus 20,000 will be 10,000. For brand C, it's going to be 24,000 minus 30% of 100,000, which will give us minus 6,000. So can we say that the value of X cannot be 100,000? It has to be lesser. So are we going to randomly, choose some value of X? We can solve it in 2 ways, like I said before. We can either start using the options, or we can look at four-wheelers expressions. So I'm going to look at the four-wheelers expressions. And if you talk about brand A, I'm saying that this 25,000 should be same as 10% of X, assuming that there are 0 four-wheelers manufactured by brand A. But do remember that every brand manufactures both two-wheelers and four-wheelers. So four-wheelers cannot be 0, but I'm taking an extreme scenario. So if this is true, so from here we will get X is equal to 250,000. Now, once I get the value of X as 250,000, if I put this value of X in brand B, C, D, E, none of them should turn out to be negative, right? So if I put 20% of X, which is 50,000, so 30,000 minus 50,000 will be negative. So brand B's four-wheeler will turn out to be negative. And we are only concentrating on four-wheelers. Two-wheelers is not our concern because the expression is not getting subtracted from anywhere. It will not help us to maximize or minimize anything. If you look at brand B, we will say that 30,000 is equal to 20% of X. So from here we will get X is equal to 150,000. So A is obviously positive, B is non-negative. Now if I take 30% of X for brand C, 30% of 150,000 is 45,000. 24,000 minus 45,000 will result in brand C being negative. So we can't take X as 150,000 as well, right? Let's move to brand C. If you look at brand C, this is going to give us 24,000 is equal to 30% of X. So from here, we will be getting X is equal to 80,000. Now, if X is 80,000, brand A, brand B will not be an issue. Brand C is definitely not an issue. Brand D is going to be 18,000 minus 20% of X, which is 16,000. 18,000 minus 16,000, D is also out of the clear, right? It's not negative. And for brand E can be any value, right? E can be in lakhs and crores, who knows? So there is no problem with brand E. So right now, this is the largest value of X that we get. If we look at brand D now, so brand D, it's going to be 18,000 is equal to 20% of X. That will result in X being 90,000. Now, if we put X as 90,000 in AB, it's not an issue. But if I happen to put this 90,000 in place of X for brand C, I will get 24,000 minus 27,000, which will make brand C negative. So, of course, the largest possible value of X is going to be 80,000, right? Now, when this happens, the number of four-wheelers for brand C will turn out to be negative. Sorry, it's going to be 0. As in, there are no four-wheelers that are manufactured by brand C, which is against the rule or the condition given in the main part of the set, right? So it should be at least 1, right? So 24,000 minus 30% of 80,000 will not result in 1. So that means we need this 24,000 minus 30% of X to be some positive value. Now, in order for this to be some positive value, right now, if I take X is equal to 80,000, this is going to be 0, right? At X is equal to 80,000, this is going to be 0, right? So can we say that going by this logic, if X is going to be some other number, so that its 30% is lesser than that, lesser than 24,000, I will not get 0, I'll get some positive value. So 80,000 is of course out of the ballpark now. Now, the next value after 80,000 is 79,990. So this is the second largest value in the options. So if I happen to take X as 79,990, so, and if I solve this, I will be getting 30% of 79,990, which will result in this calculation, will result in 7,999 into 3, right? Which will be definitely less than 24,000, and it will be some positive number. To be more precise, this is going to be a number in the table of 3. So if you solve this, this is going to result in 3, which makes sense. There has to be at least one four-wheeler manufactured by brand C. So by this logic, we are pretty sure that C is the answer. Question number 2. If 50% of total vehicles by brand C are four-wheelers, then what is the number of two-wheelers by brand A? So it says 50% of total vehicles by brand C. So brand C, we have total vehicles as 24,000, and it says 50% of 24,000, which is 12,000. These are four-wheelers, which is nothing but, as per brand C, number of four-wheelers being 24,000 minus 30% of X, right? So if we rearrange and if we solve this equation, we'll be getting 30% of X to be equal to 12,000, or we will be getting an entire X is going to be 40,000, right? As in, the total number of two-wheelers manufactured by all these 5 brands is 40,000. Now the question asked is, what is the number of two-wheelers by brand E? Now the number of two-wheelers by brand E is going to be 20% of X. Now 20% of X is nothing but 20% of 40,000, which will result in 8,000. So we should actually type in 8,000 as this is a theta question. So the answer is going to be 8,000. Question number 3. If the number of four-wheelers manufactured by brand C and D are equal, So let's go to brand C and brand D, and let's go to four-wheelers. So as per the question's first part, it's given that 24,000 minus 30% of X is same as 18,000 minus 20% of X. So if we rearrange, we will be having 10% of X to be 6,000, or the entire X, as in the total number of two-wheelers, to be 60,000 manufactured by all the 5 brands together. Now the question part is, what is the number of four-wheelers manufactured by brand A? So we need to find out 25,000 minus 10% of X. So we did not actually require the total X. We already know that 10% of X is 6,000. So we can simply subtract this and the answer should be 19,000. So option C is the correct answer. So 19,000 is the answer. Question number 4. If the number of four-wheelers manufactured by brand B is twice the number of four-wheelers manufactured by brand C. Let's take a pause here. It is given that brand B, the number of four-wheelers, that is twice the number of four-wheelers manufactured by brand C. So as per the question, 30,000 minus 20% of X is twice of 24,000 minus 30% of X. So if we happen to rearrange this, we will have 60% minus 20%, that is 40% of X, to be equal to 48 minus 30, which is going to be 18,000. So we will be getting the value of X from here. Let's not solve it further. Now the question part is, what is the total number of two-wheeler manufactured by all the brands together? So we need the value of X. So we can get the value of X from here. So 40% is 80,000. So 10% is going to be 4,500. So 100% is going to be 45,000. So we should type in 45,000 since it's a theta question. So 45,000 is going to be the answer. Question number 5. If the total number of vehicles manufactured by E is just 3% of all the vehicles manufactured. So the total number of vehicles manufactured by E, which is E, and it is given as this is just 3% of total vehicles manufactured, which is 97,000 plus E. So if we solve this, we are going to have E is equal to 3% of 97,000. Don't bother to solve this. Plus 3% of E. Now if it bring this to the other side, 100% of E minus 3% of E is going to be 97% of E, and that is going to be 3% of 97,000. So 97 and percentage, they both will cancel out. They are the same thing, so we can remove them. So we will have E as just 3,000. So question is, what is the total number of vehicles manufactured by all the brands together? So we need the total value, which is 97,000 plus 3,000, which is going to be 100,000. 100,000 is nothing but 1 lakh. So since this is a theta question, we are supposed to put in 1 followed by 5 zeros so that it results in 1 lakh or 100,000.